Okay, so your warm-up had to dealt with direct variation, and from what I was seeing or what I was hearing, you were remembering direct variation from earlier this year. And when we talked about the direct variation, I think we set up a little formula. Is that right? Did we do that? When two things vary directly, we say k was equal to, you remember this? When two things vary directly, you put them in as a fraction. And when you were doing that on your warm-up, some of you said, does it matter which one goes on top? And I said, no, as long as you're consistent, right? If you put the y on top, keep the y on top. If you put the x on top, keep the x on top. I usually put the y on top. The reason I put the y on top is because a lot of times, instead of having this k equals, we would like to put it in y equals form so that we can see what kind of an equation it really is. And to get this in y equals form, if you have it in this way set up already, to get it y equals, all you have to do is multiply by x, and we get y is equal to k times x, which is what kind of an equation if you were going to graph it? Linear, right? This is the line. So a direct variation is just something that's linear. And remember, when two things vary directly, essentially, I mean, one kind of easy explanation is, as one value increases, so does the other. Okay, that's a very basic definition. Sometimes I think about going to the grocery store and getting things from the produce department, and the more produce you buy, the more it weighs, which means the more it costs, right? So that's kind of a quick little example of a direct variation. That k is called the constant of variation, okay? And so whenever you have this y divided by x, you're always going to get that constant of variation in there. Now, what we're going to start talking about now is the inverse variation. Now, if direct variation means we take the y and the x and we divide, direct divide, that's how I remember them, what do you think we're going to do with the y and the x with an inverse variation? We're going to multiply them. We're going to end up with k is equal to y times x. And the way I think about an inverse variation is as one value gets larger, the other one has to get smaller. And that k is still your constant of variation. So let me just show you real quick. If you have x times y equals 8, for example, okay, if that were your inverse variation, you know that if x was 1, y would have to be 8, okay? If x goes up to 2, what happens to your y value? It goes down to 4, right? If your x value goes down to 1/2, what happens to your y value? It goes up to 16, okay? So as one is getting smaller, the other one's getting larger, and vice versa, okay? Now, my next question then is, what is this a graph of? The direct was a line, what's the inverse? Well, if you solve that for y, and let's just use this one to look at, if you solve that for y, what are you going to get? Y is equal to 8 over x, okay? Now, if we did a quick graph of 8 over x, let's see what that would look like. Let's see. Okay, so we already had a few points, right? We had 1 comma 8, 2 comma 4. What would be another point? 1 comma 2? 4 comma 2. 1, 2, 3, 4, 1, 2. Another pretty easy one would be 8 comma 1. Now, does that give you a pretty good indication of what's going to happen there? Yeah, it's going to curve. Now, is it ever going to get to that x-axis or to the y-axis? No. In this case, both the x and the y-axis are asymptotes, okay? It's never going to get there. Now, my other question is that the entire graph? What other values could x possibly be? Well, besides 1/2 we could find it on there, but what? Negative, yeah, like -2. If x is -2, what would y be? -4. What if x were -4? What if x were -8? What if x were -1? So it's going to look like this. This whole thing is the graph. It has two pieces. Two separate pieces make up this graph. This has a name. We're going to study it a little bit later this year, so you can, yes it is. It's a hyperbola, okay? It is. It's a conic section. But that's what these graphs are going to look like. That's their basic shape. They have those two asymptotes that they're never going to touch, okay? And it just looks like these two curves, two branches. I call them two branches, okay? So that's just the basic shape. Now, with that, pretty much all you need to know for today is that a direct variation means that we're dividing our y and our x, and that's always remaining constant. And an inverse variation means that when you multiply your y and your x, it always remains constant. So let me show you a few examples. It says, suppose x and y vary inversely, and x equals 3 when y equals negative 5. Write the function that models this inverse variation. Well, if it's an inverse variation, what always has to be going on with the x and the y? They're being multiplied. And if you were to multiply your x and your y in this case, what are you going to get? Negative 15. So your constant k is negative 15. So the inverse variation that models this situation is just x times y is equal to negative 15. One of the solutions to this happens to be 3, negative 5. But once you know this equation, couldn't you give me others? Okay. Another one might be 1, negative 15, right? I could keep going on and on, couldn't I? Do you see how that works? Okay, so could you do this one? Suppose x and y vary inversely and x equals 0.3 when y is 1.4. Write the function that models that inverse variation. Raise your hand when you think you've got it. Okay, Zach, what'd you get? 0.42 is equal to xy. Now, I guess I should actually say one other thing about both of these, because this is correct, but it does say to write the function, and typically functions are in what form? Y equals. But can you make this y equals pretty easily? It would just be y equals 0.42 over x. So when you're doing these problems, if you're checking any answers in the book, that's how they're going to write them. Okay, they're going to put them in y equals form so that it's a function. Does that make sense? You might get in the habit of doing it because then we'll probably be graphing things from there eventually. Okay? All right, let's look at this last one. It says, suppose 1.4, negative 2 is a point from an inverse variation. So one of those graphs like I just got done drawing. It says, find the constant of variation. Find k. Good, some of you already have it. John, how did you get that? Yeah. If it's an inverse variation, you should know that the constant k is just x times y. They give you an x and a y value, don't they? So all you have to do is multiply those two, 1.4 times negative 2, and you have negative 2.8. Okay? Any questions on that? Okay, then let's do this. It says determine whether each relationship is a direct variation, an inverse variation, or neither. And then write functions to model the direct and the inverse variation. So if it's neither, we don't have to do anything. Now, I think the easiest way to do this is just to try one way first. If that doesn't work, try the other way. So I usually try direct. Direct means to do what? Divide. And usually when I divide, I like to do y divided by x because that's going to be the way I'll write my equation if I do this. And what has to be true about every single time I do y divided by x if it's a direct variation? It has to be the same thing. So try it. 3.2 divided by 2 is 1.6, right? Okay, 1.6 divided by 4. I can see this already is not going to work because 1.6 divided by 4 is not going to be 1.6. So is it direct? No. So let's see if it's inverse. To check inverse, what do you do with your x and y? Multiply. Okay, 2 times 3.6 equals 4. What about 4 times 1.6? 6.4. What about 6 times 1.1? Yeah. So it doesn't work, so this is neither. This is neither direct nor inverse. You see how I'm doing that? Okay? All right, you check this one. Okay, Maddie, what do you think? It's an inverse. Why? What always happened? Okay, so you got a constant of variation that was 0.72. That means if you wanted to write the equation or the function that went with this, it was x times y is equal to 0.72. Isn't that what the inverse means? Therefore, y would be 0.72 over x. See how that works? Okay, let's look at just one more. All right, Ella, what do you think? Direct, why? Okay, did you do y over x or x over y? So if x over y is 1 over 15, then y over x would be 15. Therefore, my equation would then be y is equal to 15x. Okay? Any questions on how you did those? No? Okay. How about this one? Suppose 2, 5, and 4y are points from a direct variation. Could you find y?
Yes.
Find y. Sarah? That's it. 5 over 2 is equal to y over 4 because direct means divide, right? So you just take them and divide. Could you solve that then for y? Yep, 2y equals 20, so y is 10, okay? What if I gave you the same pair of points? I think they're the same pair. This time it's an inverse. Then what do you have to do? Do what? You multiply. So you end up with 2 times 5 is equal to 4 times y, right? Therefore, y is 2.5. Okay? Do you see how that works? Okay, good. Let's see here. I would like to look at this. Joint variation. A joint variation. All a joint variation is it's really just a special kind of a direct variation. And it's a special direct variation where you are varying directly with a product. All it means when you have a joint variation is that in the denominator, you're going to have 2 things instead of just 1. Okay? So, let me show you what I mean by that. If I give you something like this, it says z varies jointly with y. Now, there are a lot of ways that you can set these up, but my feeling is if you always start every one of them with k equals with your constant of variation, and this is different than your book is going to show you, by the way. So if you read your book, they're going to show you just a little bit differently, which is fine, but just realize it's going to be a little bit different. I just find that this method, people seem to do a little bit better. But if you always start with your constant k equals, And you remember that direct means to divide, inverse means to multiply, and joint is just a special kind of divide. They're usually really pretty easy to set up. It's saying that z is varying jointly with x and y. So joint is a special kind of direct. Direct means divide. So I know I'm going to have a divide over here. And z is going to be on top, and it's going to vary directly, vary directly with the product of x and y. So that's all it is. Okay? So a joint variation is just a special kind of a direct variation. Does that make sense? Okay? Let's look at this one. Z varies jointly with x and y and inversely with w. Now if you just go one step at a time, it shouldn't be too hard. So you're going to start out with k equals. Since it says jointly, that means you're going to have, z over x times y, because it's varying jointly with those two. But then it says, and inversely with w. Now that means z is varying inversely with w. So what has to be going on with z and w? They have to be multiplied. Well, just put that w up with that z, and now they're multiplied. Okay? Since z is varying inversely with w, we just have to multiply them. Does that make sense? Okay? All right, you write this one out. See if you can do this one. Z varies directly with x and inversely with the product of w and y. All right, Zach, did you get it? That's it. K is equal to y over x. Any questions on that? Yes. Yes, because usually what's going to happen next is then they're going to say, if z equals 5 when w equals 3 and y equals 2 and x equals 4, find w when, and they'll give you z, y, and x, and then you'll just have to find it from there. Okay? Okay, then let's see. I have 6 minutes. Let me just do this last example, and then I'll hand back your test. So it says, describe the combined variation that is modeled by each formula. What we're going to do now is we're going to go backwards. We're going to go from this equation, or this model, this formula, and we're going to go back and write things that we saw over here. Okay, so we're going to say how things vary. Do they vary jointly? Do they vary directly? Do they vary inversely? How do they vary? But the first thing that you're going to want to do is solve for the constant. Because if you solve for the constant, then the whole idea about multiplying and dividing work just like we were doing before. Now, this is a formula, and in this formula, does anybody recognize this formula, by the way, from some of your science classes? It's force. Well, do you know what G stands for? Gravity. Do you know what the M's are? Mass and? Okay. So which one of those would be a constant, a number that stays the same? Gravity is the constant. Okay. Now, a lot of times I think you'll be able to tell the constant, but in this case, it's gravity. So could you make this G equals? What would you have to do to get this G equals? Okay. So we're going to say F times D squared divided by M1, M2. You agree with that? Okay. So now, tell me about F. How is it varying with these other variables? F varies inversely with D squared and, okay, directly with the product of, but if it's directly with the product, the short way to say directly with the product of is just jointly. Jointly means directly with the product of, and jointly with m1 and m2. You see how we just went backwards? But you want to have that constant by itself first. Nope, you could have done the jointly first and then the inversely. Yep, doesn't matter. Okay? I think you should be able to tell. Okay? If you don't, then you might want to ask. Okay, we're going to say that. Okay, here is the assignment. I'll let you guys copy that down.